So for day 3, we're going to look at some applications of exponential and logistics functions. You are going to need your calculator for most of these problems, so make sure you can pull that up on your Chromebook or get your graphing calculator out. Okay, so we talked about growth and decay. So when we're setting up a formula or an equation that we want to make from a word problem, P of t equals P naught of 1 plus r to the t power. So this is the formula that we'll be using. So P naught is going to be our initial amount. R here is going to be our rate, and that has to be given as a decimal. So if they tell you the rate is 80%, then you would have to use 0.80 for your 8 naught as a percent. And T, the exponent here, is going to be time. So it's always 1 plus this. So when R is greater than 0, we will have a growth model. When R is less than 0, we will have a decay model. So think about growth and decay and what those graphs of exponential looks like. So for these examples, we want to tell whether each is growth or decay, and we want to give what that rate is. So for the first one, if you look at our equation up here, so we have 7,514 times 0.98t. So see how the 0.98 really should be the 1 plus r. So we're going to take this 0.98 and we're going to say 1 plus r, because that's what's in parentheses, is equal to 0.98. So that means if we subtract over 1, r is going to be negative 0.02. Well, we said if r is negative, okay, if r is less than 0, then we have a decay model. So this is going to be decay, and we could say it's a decay of 2%. So then for number 2, we have our 124, which is our initial. Then we have in our parentheses 1.35. So we're going to take the 1.35 and we're going to set it equal to 1 plus r, because that's the equation that's in the parentheses. So if we subtract 1, that means r is going to be positive 0.35. So because our r is greater than 0, that tells us we have growth. So this would be growth of, and if we write it as a percent, that would be 35%. Okay, so that's how our equations are going to look for our word problems here. So moving on to number 3, we just have a little example here. So the population of River City was 4,200 in 1910. The population increased by 2.25% per year. Okay, so things that we know from here. This 4,200 is our initial amount. And then the population increased. So increase means we're going to use positive by 2.25% per year. So that means our rate is going to be positive. To change your percent to a decimal, you can move your decimal 2 places to the left. So 0.0225. So for the first part, we want to estimate the population in 1945. Well, first thing, 1945, we're going from 1910 was the initial. To figure out what our t is actually going to be, we can take 1945 and subtract 1910 from that. So our t is going to be 35. So 35 years we're going to use for t. So we're going to make our equation. So P of t equals our initial amount, which we said was 4,200, parentheses is 1 plus the r value we said was 0.0225, and then that's always going to be to the t power. So that's our equation there. Initial is 4,200, parentheses 1 plus 0.0225t. So they want us to figure out when t is 35, what is this going to be? So we're really just plugging in 35 here. So it's going to be 4,200 times 1 plus point, and if we want to, you can go ahead and add that together. make it a little neater. So if we add these together, that would be 1.0225. That's going to be to the 35th power. So you're going to use our calculator here, and you're just typing this into the regular calculator. So we have 4200 parentheses 1.0225, and then our exponent here is 35. So our population of people is going to be 9,150, and I'm going to want to put the decimal here. Okay, but because it's people, we need to round, and we'll round to the nearest whole number. So this will be 9,151 people for our population there. Okay, and then moving on to part B, when. So when means we're trying to find time. Did the population reach 20,000? So population P of T, we're saying is 20,000. So we're going to use our same formula that we used here, this P of T that we made. I'm going to put a box over this. But our P of T we're going to use as 20,000 equals 4,200. And then in parentheses we have 1.0225. And then we're trying to find the time this time. So what you're going to do when you have the two equations equal to each other, we are going to use the graph on the calculator. We're going to put one side in y1 and one side in y2, and it doesn't matter which one you put where. So if you go to the graph on your calculator, so in y1 I'm going to put 20,000, and then in y2 I'm going to have 4,200 parentheses 1.0225, and that's going to be to the x power. Now, I see that I have 20,000 here, so we are going to have to fix the window. So I'm going to go to the window. I'm going to change my x max to 100, but my y max is the one that really has to change. It has to be bigger than 20,000, so I'm going to put like 25,000. I'm going to go ahead and graph this. As long as you can see where the blue line and the red line intersect, then you're good. And I'll just draw like a little picture here. So we want to find the intersection. And I'm just writing on this, so you just want to find the intersection there. Okay, so we're going to do second trace and then number 5, which is intersect. Because there's only one, you can just hit enter 3 times. So 1, 2, 3, and it will say intersection. So x is really t here. So t is 70.139, so we'll round that to 70.140. And t is in years. Okay, so that is our t value. Now it said when, and remember they referred to this starting in 1910. So first off, we're going to go ahead and round this up to 71 years. Just because it's already into that, if it's 70 point, it's already like into January, February of that year. So 71 years. And we're going to take our original year that it started at 1910, and we're going to add 71, and that'll put us in 1981. So in 1981, we would have that population of 20,000. Okay, so moving on to the next one. So the initial mass of an object is 15 grams. But its mass decreases by 0.9% every hour. What is the mass at the end of one full day? Okay, so let's just write down everything we know. We know the initial here is 15 grams. We know the rate is decreasing, so it's going to be negative. It was 0.9%, so if we move our decimal twice, it's going to be 0.009. And then we know that time t is going to be in hours because it says every hour. Okay, so to make our equation P of t, the initial we said is 15. It's 1 plus, but because we have decrease, it's going to be 1 minus the 0.009 to the t power. Once again, t is in hours. So it says, what is the mass? So we're trying to find P of t at the end of one full day. Well, one full day in hours is going to be 24 hours. So we're trying to figure out what, when t is 24, what is p? So we're going to do p of 24. We're going to plug in. And this is not one where you're finding the intersection, you're just trying to calculate. So we're just going to go in the regular calculator part, and we're going to just type in 15 parentheses 1 minus 0.009, and that's going to be to the 24th power. So that is going to give us 12.074, and I'm going to keep my 3 decimal places. We're talking about a mass here, so it can have decimals. It's not talking about years or talking about people there. So we can have that decimal there. So we're going to end up with a 12.074 grams.